Hey guys, welcome to our last week of classes. And we're going to have two lessons this week. We're going to have 12-5 and 12-6. And if you're watching these videos, any notes that you take on the two videos can be used on the quiz on Thursday. So for those who are not watching, and you don't know what I'm saying because you're not watching this, you won't be able to use those notes. But if you watch the videos, and as you have been before, you get to use those on the quiz, and that quiz will be the last grade of the quarter, and that'll be on Thursday, okay? So it'll be on 12-5 and 12-6. Okay, so today we're talking about volume, and you guys have heard of volume, and maybe you've heard of prisms and cylinders, but we're definitely going to look at volume because we've already looked at area. So we look at lengths, and then we look at how many of these square units I can fit inside an object, and now I'm looking at how many cubes I can fit in an object. So a cube, I'm going to draw my best simple cube. A cube is a three-dimensional object, so it has length, it has width, and it has depth or height. And that 3D object is used to measure space. So we've been measuring like distances from point A to point B. That's one direction, that's one dimension, so here to there. You just say meters. If I'm looking at like a surface, like a board or a wall or the ground, I can use square meters. But then when I'm saying like in my room, how much room do I have in my, how much 3D room, three dimensions, I say length, width, and height. And then I'm asking how many of these cubes can fit into my room, and then I can make better decisions on it. Okay, so here's a basic cubic unit. It could be a cubic inch or cubic centimeter, cubic mile, which, by the way, a cubic mile is 1 mile long, 1 mile wide, 1 mile high. So that's a huge cube, but you can use that to measure things like the Earth, because the Earth is huge. So there are a lot of these cubic miles that can fit on the Earth. So here, like if I had an object, and I'll make sure I draw this the right way, a rectangular prism. So here's a rectangle, and here's another rectangle, but I'm going to do something with that. I'm going to connect them. And then, yeah, I guess I don't need to draw those dotted lines. Okay, so that's a rectangular prism. The reason we call it rectangular is because the bases are rectangles. So the base faces are rectangles. So I'm asking, for example, if I say find the volume of this rectangular prism, how many of these cubic units can fit into this rectangular prism? And then that's how you're going to get your answer. You're going to say something cubic units. So cubic feet, cubic miles, whatever the units we're dealing with. Okay, let's say this rectangular prism, well, let's just go, it had a length of 8. It had a height of 3 and a width of 10. Okay, so the length is 10. We could say the length. It doesn't matter what you call them, but you have three dimensions. So you have length and height and width, and those are the dimensions. So how do you find the volume of a prism? It's to find the volume. So we're going to call it V. This is how you always do it, which is really cool. You're going to say capital B times H. Okay, have we seen H before? Yes, it's your height. Okay, the height of a triangle, the height of a trapezoid, the height of a prism. That lowercase h has always been height. We've used B before for base, but that was lowercase b. When you have a capital B, I'm going to write it out here. Capital B means area of base. Area of base. And you're like, wait, I thought area was capital A. Okay, when you're dealing with 3D objects, volume, you are going to use the area and you're going to use a height. And this is the basic formula for all the problems in our lessons today and tomorrow. But B stands for capital B, so it's like it's part of the volume. It's not just area, it's the area so that I can find the volume. Okay, so let's find the area of the base. What kind of base does this rectangular prism have? Well, the name says it all. The base is a rectangle. So the base, you can call it, is 8. So the base is a rectangle. Okay, so let's see. How do you find the area of a rectangle? You do base times height. Do you guys remember doing that? Okay, so it's like its own, or sorry, it's a rectangle. So we'll go with length and width. That'll make it easier. So length and width. All right, the length of this base, we'll call it 8. The width we'll call 10. And that's going to give me 80. So the area of the base is 80. So right now we have volume equals 80 times, and then what's the height? 3. So we do 80 times 3, we get 240. So how many of these cubic units can fit into this rectangular prism? We would say 240 cubic units with the little 3 right there. Cubic units, that would be my answer. You can fit 200, and these are obviously bigger. My scale's really off, but maybe it'd be something like, how many of these guys can you fit in there? 240 cubic units. That's what we're asking for. Okay. And I know the lettering and all that can be confusing, but I'll try to make this as easy as I can because this will apply to both lessons, even when we're dealing with pyramids and cones, which will be tomorrow's lesson. Okay, I'm going to see if I can draw this one here. This is testing out my drawing skills, which I lack very much. Okay, we're going to pretend that's a this one is a triangular prism. And the reason we call it a triangular prism is because it has 2 faces. See these 2 triangles that are exactly the same. They're the same area for those faces. And then these 2 faces are parallel to one another. So that means, these 2 faces, they won't ever intersect even if you expanded them. And then it has a height. The distance between the 2 faces, this distance is called the height. Okay, so then I'm going to give you some info. Okay, I see. So we're going to make this, I'm going to give you this is 6 centimeters. So this distance is 6 centimeters. This is going to be 4 centimeters. This is a right triangle. And then the height is going to be 25 centimeters. And they give you they say that the height is 25 centimeters. Okay, first, to find the volume of any prism, you do the base times the area of the base times the height. Okay, so what kind of base does it have? A triangular base, because it has 2 triangular faces that are exactly the same. Yes, it has rectangles on the side, but they don't have 2 rectangles that are exactly the same. So these 2 triangles, how do you find the area of a triangle? How do you find the area of the base? And you can do either base because they're both exactly the same. For the area of the base, which is a triangle, so this is like capital A, which is referring to that B, right? Is 1/2 base times height. Okay, so we're just talking about this triangle. So 1/2, and then you can call 6 the base for the height. 1/2 times 6 is 3. 3 times 4 is 12. So I get 12 square centimeters. 12 square centimeters for the area of the base. So volume equals 12 square centimeters, which we'll leave it there. And then the height, the distance between the bases, is 25. So then what I have to do is multiply these 2 together. 25 times 12. And that will give me the volume in this case. So the volume would be 300 cubic centimeters. So 300 cubes that are 1 centimeter by 1 centimeter by 1 centimeter, that would be your, that glare is coming out pretty strong. But that would be how many of those cubic units you can fit into this prism here, this rectangular prism. So I'm going to close that up and get some. Sorry guys, I had to adjust that lighting. It was giving it still is giving a weird glare. guys, with me recording, the glare is going to be something I'm always going to face because the glare is always so bad in my room, wherever I'm at, no matter where I go. But that's how you find the volume of that triangular prism. Two triangles, that's the faces, triangular prism. And guys, you know how we memorize the polygons? So like triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon. Okay, all those have their own names for their prisms. So like if you have an octagon for the two bases, you would call it an octagonal prism. And that idea of octagonal, pentagonal, hexagonal, that also applies to tomorrow's lesson with cones and pyramids. Okay, the second type of problem you're going to get is you're going to deal with cylinders. Okay, so a cylinder does not have a polygon for its bases because a circle is not a polygon. It has circles as its bases. So you see the two circles, they're exactly the same, and then they have a height. So let's figure this one out. So you'll get like a little dot there in the middle, and then the radius in this one, 6.8, 6.8, and then the height's going to be 4.5, which my diagram does not show at all. It's terrible, by the way. Anyway, I know it's hard to see, but that's 6.8 and that's 4.5. So to find the volume of a cylinder, okay, to find the volume of a cylinder, all right, here's a new formula. Volume equals base of area base times height. It's the same formula. The only difference here is, and the reason I do this, guys, is because in geometry in high school, you're going to get all these problems, and they're going to make you memorize a bunch of formulas, and you're like, it's a full page of formulas. There's a formula for that. But I'm trying to make it as simple as possible. All the volumes can be found this way, all of them. You just got to know what kind of base you're dealing with. Okay, so what is the base of this cylinder, which you can almost call a circular prism, if you wanted to say it, but that's not really a term. But circle has its bases, and then they're parallel to one another. They're parallel, and they have a height between them, or distance between them. It's a circle. How do you find the area of a circle? Pi r squared. Okay? So here in this case, the radius is 6.8, and we're going to use 3.14 times 6.8 squared. And I'm going to look at this lesson to see where they want us to... Okay. In this lesson, they're also going to give you an option. If you have... I want to make sure I say this correctly. If you have a decimal number, use a decimal version of pi. But I don't know if any of you know what the non-decimal version of pi is. So what do we round pi to if we don't want to have a decimal? And that's basically what's the fractional form of pi? And that would be 22/7. So I'm going to put here off to the side for your notes. Pi is almost 3.14, so we use that, or 22/7. Now the times I use 22/7 really is when either this is not a decimal, or this is a fraction, or this is a number that can be divided by 7 easily. So you'll have an option to use either one, and I'll show you a problem where you might want to use this one. Okay, anyway, let's keep going. 6.8 times 6.8. 6.8 times 6.8 is 64, 48, 54, 0, 6 times 8, 48. Sorry, I'm starting to think of other things. 48, 36, 40. Okay, 4, 12, 6, 4. Put the decimal point. 46.20. 46.24. Make sure that's good. Then I'm going to multiply that by pi. So it's going to be 46.24 times 3.14. Okay, so I'll do that real quick over here on the side. So that'd be 16, 8, 9, 24, 18. Bring down a place value holder. 1 times 4. 1 times 2, 1 times 6, 1 times 4, 0, 0, 2 place value holders because I'm going out here. That's 12, 7, 18, 13. Make sure I keep that all on track. 13, 5 plus 4 is 9, 14, 21, 6, 10, 15, 4, 1. Bring the decimal 4 places. Okay, so 3.14, so 145.15. And then I have to multiply that by the height. But I'm going to say this, guys, when you're dealing, find the area of a circle, you can round it to the nearest tenth. So I'm going to say 145.2, 145.2, and then I'm going to multiply that by the height because all I did was find the area of the base. So now I have to multiply by the height, 4.5. Okay, so now I'll do this last one. Okay, I'm gonna work it out on the calculator because my time is running out and I don't want to take out all your time. So 185.2 times 4.5, 653.4, 653.4, 653.4, and we were talking here cubic yards because we're talking about a volume for this cylinder right here. Okay. So I would use 3.14 and I'd find the area of the base. So first I did 6.8 times 6.8 and that gave me 46.24. Then I multiplied that by pi. I got 145.1936, round it to the 10th. But that's just to find the area of the base. Then I multiply by the height and then I get my 653.4 cubic yards. Okay. So what I have to do with that is remember, this is the base formula, and for a cylinder, that means you have to find the area of the base and then multiply that by the height, no matter what. Okay, I'm going to leave it with that one. If you don't ever want to use 22/7, you don't have to, but that's an option if you want to deal. There are no fractions on the homework, but if you wanted to use it, you could. It might make the math easier on some problems. Okay, your homework is going to be 6 through 16 even. And remember, any notes you took from this lesson, you could use for your quiz on Thursday. Just remember that. So numbers 6 through 16 even. And that's going to be on page 369, 370. 369, 370. Okay, so you'll do those problems, and then don't forget, you're using the same formula. Volume equals area base times height. You just got to know what the area of the base is. So I hope you do well on that, guys, and please send me questions if you have any. All right, see you guys.